Hi, everybody, and welcome back. Today, I want to talk to you about combinations and permutations. What's the difference between these two? When do you use one over the other? But first, I want to remind you, if you have an engineering degree from outside of US and you would like to evaluate your education in this country, I have put together a PDF guide with step-by-step instructions on how to do that. So just click the link below and you'll be able to download it for free. Now let's move on. So, a combination is a particular set of objects created without regard for the sequence. In other words, order does not matter. I'll give you an example. If we were to take a set of 3 numbers, 1, 2, 3, and I would like to know how many groups of 2 out of these 3 numbers I can create, we can do 1, 2, we can do 2, 3, and we can do 1, 3. There are no other groups we can create. Answer is 3. If we go to permutations, a permutation is a particular sequence of a set of objects. Each sequence is unique. In other words, order matters. That means if I take the same 3 numbers and I would like to create groups of unique sets of 2 numbers, I will have 1, 2, and I will have 2, 1, right? And then I'll take 2, 3, and 3, 2. Since the order matters, these 2 are not the same. These 2 are unique. And lastly, I'll have 1, 3, and 3, 1, meaning the answer, I have 6 unique sets of numbers. So now let's work on a few examples. Problem number 1. A community organization is putting together an event where 4 speakers will be on the program. The committee can choose from a pool of 7 candidates. A, how many groups of speakers can be created? B, how many unique programs can be created? So right away, when you read the problem, you can define that N, your N is 7, and R equals 3. So for A, it asks us how many groups of speakers can be created. It doesn't specify about the groups being unique. They don't care about that. So right away, you're thinking about combination of 7, 3 equals 7 factorial over 3 factorial, 7 minus 3 factorial. This will be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 7 minus 3 is 4, so I will have 4 times 3 times 2 times 1 equals 35. Now B, how many unique programs can be created? So B asks us about how many unique programs, which right away sends you to the permutations because it's asking us about a unique sequence. So we will go ahead and do the permutation, which is equal to 7 factorial over 7 minus 3 factorial equals 2. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4 factorial, which is 4 times 3 times 2 times 1 equals 210. Problem number 2, a bridge has 12 lightning pedestals as part of its superstructure design. Each pedestal is capable of supporting 1 light post. If 6 identical light posts are available at a certain stage of the project, how many unique lightning arrangements can be created. Now, this is an interesting one because once you read the question, how many unique lightning arrangements can be created, right away, you are thinking about permutations. But the trick here and the key word here is the identical, is this word right here. So think about the posts, they're all the same. So it doesn't really matter in which order you place them in a group because it's going to all be the same, right? So this is a tricky problem here and you have to pay attention. The answer, it's still combinations of 12. We have six posts and the answer will be 12 factorial over 6 factorial, 12 minus 6, and then you do the calcs. Problem number 3. A bag contains 10 green, 6 yellow, and 4 red balls. How many unique sequences of 20 balls can be made by drawing from the bag? Now, let's see. I would like to go to FE reference handbook and show you these are all the formulas that are provided to you during the exam. This is the permutation formula, combinations, and then this is the third formula that we are going to use in this problem, which is the number of different permutations of n objects taken n at a time. So we have 20, 10, these are our case, 10, 6, and 4, which equals to 20 factorial over 10 factorial, 6 factorial, 4 factorial, which equals 2, so on, and then you just do the math and you find your answer. So now I would like for us to go back to our problems because I don't want you to do any hand calculations when you are doing the exam because you can use your calculator to solve all these combinations and permutations to save you time. So let's go back and see how you can easily do this and be done in a few seconds. So now I would like to show you how you can solve these problems that we just did earlier by just typing a few buttons on your calculator. Let's go to problem number 1. So we had a combination 4 speakers out of 7. So when you have combinations of 4 speakers out of 7, go back to problem number 1. What you do on this calculator, you type 7, enter, and then you type 4. And once you type 4, you go and look for your combination on your calculator. In my case, if you're able to see it, hopefully, it is right here. I have MCR, and it's yellow, which means I have to push this button first to apply this action. So I will do, there you go. And I got 35. So remember, we got 35 as well. So just by typing these these buttons, you get a result instantly. Now let's go back and do the permutations of 7 speakers, unique 4 speaker list. So again, we're going to do 7 and 4. So you see here on my screen, I have 7 and 4. And then I'm going to go ahead and look for my permutation action on my calculator. And I'm not sure if you can see it here. It's, I have an NPR blue here, and which means I have to press this button first to activate the blue action on this button. So I will do that, and then, and the result is 840. And if you go back to our problem, you will see that we got 840. So the same way you can do the other problems by just typing a few buttons on your calculator. I want to remind you that if you have an engineering degree from outside of US and you would like to evaluate your education in United States of America, I have put together a PDF guide with step-by-step instructions on how to do just that. Just click the link below and you'll be able to download it for free. If you found this video helpful, don't forget to subscribe and give it a like. This helps people like you find me. I will see you next time.